Alright guys, decided that I felt a little bit bad that we hadn't gone through all of example S because I was running out of time. I can only post 15-minute max videos to YouTube, and that's why I got this countdown going on up here. So I thought maybe now I'm starting just a part 4 that perhaps I should just kind of erase all of this and just sort of show you a complete solution. This is certainly a much more challenging problem, and so let's do it all in full, and hopefully we'll agree on our solution by the time we get to the end. And I might also solve it using a calculator so we can compare. So here we go. We said that we would begin by isolating one of the absolute values. That's been done for us, and so as I take away the absolute value sign, my first situation leaves the right hand side as is. This is an AND situation because the absolute value is less than. And my other case, my inequality switches sides, and the right-hand side becomes a negative of what it currently is. So let's isolate the absolute value in each of these situations. I find it easier to put it on the left, so we'll put our absolute value on the left. And that means that the inequality is changing directions here because I'm just expressing this inequality in reverse order. This absolute value is greater than x plus 4. And if I want to move this one to the left-hand side, let's just add it to the left. It becomes a positive. And if I move these ones over to the right-hand side, they become a negative. Okay. Now that my absolute values have been isolated, let's split each of these into two cases. So as I take away my absolute value sign, I can see the absolute value is greater than, so that's going to be an OR situation. Or my other case is 2x minus 2 is less than the opposite of the right-hand side, so everything becomes negative. And my other pair of cases, as I take away my absolute value sign, 2x minus 2 is greater than negative x minus 4, or, because the absolute value is greater than, 2x minus 2 is switch the sign, and it becomes the opposite of what it was. Alright, let's solve each of these pairs of compound inequalities, and at the very end we'll stick them all together. So my first one, if I move my x's to the left, it becomes a negative x, so 2x minus x leaves me with just 1x is greater than, and my negative 2 moves to the right, becomes a positive 2, so that's a 6. Or, let's move the negative x to the left, becomes a positive x, I've got 3x, and my negative 2 as it moves to the right becomes a positive 2, yielding negative 2. So this means that x is greater than 6, or x is less than negative 2/3. And if you graphed that to see if it could be simplified, we'd end up with x is greater than 6, or less than negative 2/3. Okay. Let's now solve the second pair of cases. And in our first case, the negative x moves to the left, becomes a positive x. It's 3x. The negative 2 on the right becomes a positive 2, and that gives me a negative 2. Or, if I move the x to the left and subtract it, it becomes a 1x, and the negative 2 moving to the right becomes a 6. So let's look at x is greater than negative 2/3, or x is less than 6. And if I graph that situation, x is greater than negative 2/3, or x is less than 6. Oh, so in this situation we've got all reals. So let's look now at these two overall solutions. We've got all of this stuff, x is greater than 6 or x is less than negative 2/3, and all reals, meaning we're looking for the regions of overlap between this graph representing the first pair of cases and this graph which represents the second pair of cases. Well, thankfully this overlaps with everything, and so the total region of overlap will be these two solutions, and your final solution then, x is greater than 6 or x is less than negative 2/3. And I want to show you another way that you could have done this using the calculator. So let's go over to our y equals, and we'll just clear these two equations that were in there already. And so my left-hand side is going to be the absolute value of x plus 4. I can make an absolute value sign in Math Num menu, and it's option 1. The absolute value of x plus 4. And my right-hand side is the absolute value, so Math Num abs, of 2x minus 2. Alright, now then, I'm looking to see where is my first equation, where is y1 less than, meaning below, y2. So where is my first graph below my second graph? Let's have a look. There's my first graph. Where is it below the second graph? Well, I can see it's below the second graph everywhere here, and also everywhere to the right of that point, I suspect. Let's change the window a little bit so I can see more information. So I'll press Window, and I'm going to increase my range. Maybe I'll look all the way to x max of, say, 15, and I'll change my y max to 20, so I could just see a little bit higher up on the graph. Now let's graph it. There's my first curve, my left-hand side. There's my second curve, my right-hand side. Where is my first curve less than my second curve? Everywhere here, so everywhere to the left of that intersection point. And everywhere here, everywhere to the right of that intersection point. To find those two intersection points, we'll say second, trace, calculate, intersect. Yes, that's my first curve, enter. Yes, that's my second curve, enter. And then let's put in a guess that looks fairly close to this intersection point. X equals, say, I don't know, maybe negative 1. And we find out that the actual intersection point occurs when x is negative 0.6666667. I hope you can recognize that as x is less than negative 2/3. And our second intersection point, second graph, intersect. That's my first curve, enter. That's my second curve, enter. And my guess, that looks to be crossing around 5. So let's guess that they cross at 5. In fact, they cross at an intersection when x is equal to 6. And there's the other part of my intersection. And so a quick graph to justify coming up with a solution with no algebra. So here's my first curve, and here's my second curve. And then we just need to show that these intersection points occur at, well, whatever they were. That was an x value of negative 2/3, wasn't it? And that's an x value of 6. And I should label them. This was y1, which was, sorry, let me just move that over a little bit. So that's y1 is equal to the absolute value of x plus 4. And the second curve, let's label it there. y2 is the absolute value of 2x minus 2. And I can see then that my absolute value of x plus 4 curve is below the other curve in this region here and in this region here, which is that solution there. And so that graph would be sufficient as a graphical justification if it was a calculator question for how you could come up with a solution much easier than splitting into two cases and then each case splitting into two further subcases and then sticking them together with ORs here, sticking them together with ORs here, and then sticking each pair of cases together with the giant AND. That's complicated. So let's hope that you can also solve it with a calculator and make your process much easier.